Assalamualaikum warahmatullahi wabarakatuh. We are from Group 12. Today we would like to present our mini project. The first thing is introduction. The KY-032 effect obstacle avoidance sensor is a popular electronic component used in robotic and various automatic automation projects. It is designed to detect obstacles in path using infrared light, making it engineered tools for autonomous navigation. The sensor emits infrared and detect the reflection from nearby objects. Many KY-032 modules come with a potentiometer that allow user to adjust the sensor sensitivity according to their needs. The sensor typically provide a digital output, high or low, indicating whether an obstacle is detected. Its small size makes it easy to integrate into various projects, including robots and automated vehicles. Application the KY-032 provide obstacle avoidance sensor to industry. Use it in line following robots and obstacle avoidance system, employed in automatic vehicles and smart home device for navigation and safety. Can be used in application requiring proximity detection, such as the automatic doors. The KY-032 sensor is fundamental component in many robotic projects, providing additional functionality for detecting and avoidance obstacle.
For methodology, an IR sensor, short for infrared sensor, is a device that detects objects using infrared light. It's a common component in many electronic device and system, particularly in robotics and automation. This is the project parts and the components. They will need KY-032 infrared obstacle avoidance sensor, Arduino or any microcontroller, LED, and resistor for the LED. For expansion of input and output, the KY-032 infrared obstacle avoidance sensor is our main input. It works by emitting infrared light and detecting the reflection from nearby objects. The sensor has digital output, high or low signal based on whether an obstacle is detected. For output, the LED will be used as the output. When an obstacle is detected, the LED will turn on. When there is no obstacle, the LED will turn off. How the circuit works, they will need power supply, sensor output, and the LED controls. The power supply, the KY sensor gets powered by the 5 volt pin of the Arduino, and the LED is powered by the same 5 volt source, but it requires a current limiting resistor to prevent excess current from damaging it. For sensor output, the KY-032 sensor sends a high signal when an obstacle is detected and a low signal when no obstacle is present. This signal is connected to a digital input pin on the Arduino, for example, pin 2. There is for the LED control, the LED is connected to a digital output pin on the Arduino, for example, pin 13. When the Arduino receives a high signal from the sensor, it will turn the LED on. When the sensor output is low, no obstacle detected, the LED will be turned off. For circuit diagram, this is the circuit for this is the circuit diagram for our project, the KY sensor 32 and the for LED. Circuit description, the KY-032 sensor is connected to the Arduino with its out pin connected to pin 2 of the Arduino. The LED is connected to pin 13 of the Arduino through a 220 ohm resistor to limit the current. The ground pin of the Arduino connects to the sensor and the LED is scattered. This is the coding for Arduino.
So for result, Autocad infrared obstacle avoidance sensor KY-032. This is for side view for the Autocad for the sensor. Okay, next. And this for view for resistor and LED. And for freezing, we have a breadboard view and schematic view. And lastly, for KitKat, schematic circuit design for PCB and 3D view for PCB.
Okay, so let's jump into the discussion. First of all, we face some difficulty. For example, sensor calibration. The problem is initial calibration for the KY-032 sensor was challenging as the detection range and sensitivity was sensitive to environmental factors and power supply variations. So the solution is to experiment with different potentiometer settings and power supply voltages to fine-tune the sensor's performance. We also implemented a calibration routine in the software to adjust the threshold dynamically based on ambient conditions. Next, we also face obstacle avoidance algorithm problem in developing a robust obstacle avoidance algorithm that could handle various scenarios. For example, multiple obstacles, narrow passages was complex. So the solution is we started with a simple algorithm that will stop the drone upon obstacle detection. As we gain experience, we implemented more sophisticated algorithms such as wall following and obstacle avoidance using ultrasonic sensor in conjunction with infrared. And last but not least, power consumption and battery life. The problem is the drone's power consumption was high, especially during active flight and sense operations. So we optimize the code to reduce unnecessary computation and sensor readings. We also explore using low power components and efficient power management techniques to extend the battery life. To conclude, through this project, we gain valuable experience in hardware integration, software development, problem solving, and also teamwork and communication. So last but not least, here's some recommendation. So that's all from us. Thank you.